Hello everyone. Today I will introduce a core technology that is ubiquitous in the field of automatic control, PID controller. Whether you are institutes uh, in smart cars, industry robots, or drones, understanding PID is an essential step. So let's officially start today's sharing. Firstly, we will enter chapter 1 to provide an overview of the base principles of PID control. We will first clarify what the three letters PID represent and how they work together. To understand PID, we first need to look at its family portrait, which is a classical closed-loop control system diagram. The system has a tag wallet, such as the speed we want the car to reach. The controller, also known as our PID, calculate a control variable based on error between the current wallet and the tag wallet to drive auto actuators such as motors. And changing the state of the controller address like carvings. Then the session will measure the current state again and provide feedback to the controller following a closed loop. How does the brain of PID controller work? It consists of three core components and proportional components, which is the most direct. The larger the error, the greater its output. Striving to quickly reduce the error. The integration process is very pattern and accumulate past error. Specifically decide to eliminate a small static error that still exists after the system stabilizes. And in the differential stage, it's the most visionary, able to predict the future change of error trains, which in advance and prevents the system from going too far. Now, let's delve into how these three stages work. The proportional aspect is like a quick rending decision make. When the error is large, it will use strong drugs to rapidly increase the output and quickly pull the error back. But when the error decreases, it will also gently reduce the output to avoid overshoot caused by SEC force. The integral process is like a memory current as long as the errors still as it is. even if it is small. It will accumulate B by B. Continue also playing pursue unit error is ultimately eliminate to zero. That's why it can improve the controller accuracy of the system. The different process is more like a profit to who can process the future. It doesn't look at how big the error is now, but at how fast the error is changing. If the error is repeatedly approaching change zero, it will stand on break in advance to prevent the system from using over. Seriously be reducing overshoots and allowing the system to stability faster. Okay, with an understanding of the base prices of PID, the next key question is how should the force of the proportional integral and derivative stage be allocated? It leads to our second chip, parameter tuning of PID controller. Why is the programmer tuning so important? Because three parameter of PID, KP, KI, KD, derived data determines the personality of our system. KP data determines how fast the response is. KI determines how high the accuracy is, and the KD determines how stable the system is. They collectively affect the response speed, overshoot adjustment time, and the stability of the system. It can be said that which good parameter tuning an ordinary system can perform exceptionally well. If not properly tuned, the system may even fail to work stably. For more intuitive understanding, let's take a look at this picture. This graph shows how the step response current of the system changing range, KPKI and the KD change, especially for increasing KP may reset in faster response. But overshoot may also increasing KP can eliminate steady state errors, may cause the system to oscillate more severely. Increasing KD can effectively suppress overshoots. Through this graph, we can understand that programmer tuning is a process that requires chart of and optimization. So how should it be specially adjusted? There are three ways principally here. Firstly, select programmers based on system currents, just like a doctor need to prescribe the right medicine of a quick response system. We can use a large KP for also response system. We need to more patterning with a smaller KP and the large KI. Secondly, gradually adjust. Do not attempt to adjust all parameters at once. The classical sequence is first adjust is the progression like P uh, to make the system uh, basically move. Then add integral to eliminate state areas. Finally, add a different nation to suppose surprise overshoot every step requires or showing the system is a response and making process adjustment. Thirdly, consider the response needs of the system. We cannot only pursue the base performance in idea elements, but also consider whether the system remain stable even when disturbable. Our sensitivity parameter may cause the system to lose its temper at the slightest disturbance. So stability is also the top priority. After discussing the theory, let's take a look at how PID control can perform well in the real world. In chapter 3, let's explore several classical applications expressed that you will find very close to us. The first explore the first example is a common practice in our daily lives. Temperature control. Temperature control. For example, the air conditioner at home might time the temperature you set through PID agreement agrees. When the room temperature is much lower than the set volume, it will stronger cold PF when approaching the set volume. It will reduce power and gradually eliminate to the temperature difference IF. At the same time, it also predicts the chance of temperature decrease to prevent overcooling defect. Induced in industry, whether it's metallurgy, chemical, or pharmaceutical control, precise temperature control cannot do without PID. The second example is liquid level control. Imagine a huge stronger tank in a chemical plant, where we need to maintain the liquid level precisely at a certain higher. The PID controller will monitor the cycle from the liquid level station in real time and compare it with the tag high. If the liquid level is low, increase the opening of the inlet level. If it's approaching slowed down and volume opening, speed to prevent water from overflowing. This simple and reliable control method ensures the safety and stability of flotation. The third example, which is also the most interesting of many students, is speed control. Both the width of the intelligent car we are researching and the genes of the robot require precise speed control. The PID control means the ultra speed of motor slow and encode. Compare it with the tag speed and dynamically adjust the one one tag apply to the motor. In this way, we can make the car run fast and stable, and make the robots movement precise and smooth. No technologies is perfect in chapter 4. We will adjust objectively acknowledge the advantage and the disadvantage of PID controller in order to have a more comprehensive understanding of them. Firstly, let's take a look at outstanding advantage of PID controller. Firstly, it's simple and easy to use. It's structure is very intuitive and does not require complex mathematic models, making it easy to engineer to understanding and implement. Secondly, it has strong robustness. This means that it's insensitive to small scaling changes in the parameter of the controller object, and the system will not lose control due to even a small aging or environment change. Environment changing. Thirdly, the control accuracy is high as long as the parameter are properly tuned. PID can achieve very high control accuracy, meeting the needs of the vast major of industrial applications. Of course, PID also has its limitations. Firstly, it's not effective of a system with high latency. If the response delay from input to output of the system is long, the productive ability of PID will fail, which can easily lead to sensor overshoot and oscillation. Secondly, there are also small limitations in dealing with non-linear systems. For complex systems with non-linear we have characteristic fixed PID programs are difficult to achieve optimal performance at all operating points. Thirdly, program parameter adjustment is actually an art. Although there are means to follow finding and optimal set of programmers often requires rich expense and a lot of trial and error, and the process is quite complex. So, how can we overcome this shortcoming? How can we overcome this shortcoming? PID controller is also constantly overlink. For example, combining artificial intelligence with intelligent PID can automatically find the optimal uh, parameters at the PID, then can self-adjust according to system change and a multi-variable PID that can handle multiple inputs and outputs simultaneously. These developments have brought new vitality to the classical PID technologies. Finally, in chapter 5, I would like to share with you some very useful tips of practical application of PID controller, which may not necessarily be learned from book. The first technique is about anti-interference. The real world is full of noise and interference, which can disable our controller. We can combat it in 3 ways. Hardware filtering, such as editing competing competitors to the secure software filtering, such as using programmers to smooth the collect signals. And the signal is a solution to prevent high power device from interfering with other control circuit. The second and the most important technique is the practical method of programming steering. In addition to the principles we mentioned earlier, there are 3 specific operations here. Programmer turing itself, which is an intuitive process, step response test by giving the system a step signal and assuming its profession question code to determine the quality of program parameters and the dynamic arithmetic analysis using profession tools to evaluate the and ultimate system performance. The last tip is about system maintenance. A good controller system is not only about design, also about maintenance. Regularly check like a physical examination to see if the wearing is secure and if the equipment is clean. Familiar with 4 denotes about able to quickly locate the cost-resistant encounters problem and reserve spare parts. Key sensor or actuators can be replenished immediately if they are damaged. Uh, this these 3 points can ensure the long-term stable operation of your system. The above is complete introduction about PID controller. We start with its base parameters, explore parameter during analyze practical application and share advantage, disadvantage, and practical techniques. I hope this sharing can help everyone better understand this powerful or in the classical control tool. Thank you all for watching.